Okay. 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 Chat on the side. Twitch is not easy. Certainly not easy. Cool. So now we are looking at this RFC, and we are going to make logging channels configurable. So first of all, look at how things are supposed to be configured. So we have these configuration options that today are pretty complicated and difficult to mix and match together. And so this RFC proposes to have a more homogeneous configuration mechanism with some kind of DSL in the command line. DSL means that on theory we could imagine a world where this configuration goes into a configuration file separately. But for now, CockroachDB takes all this configuration on the command line for reasons. And we're going to follow this pattern, but makes it more flexible, nevertheless. So we have logging channels inside CockroachDB, and we want to make them configurable, go to different places with different parameters. And so we have configuration formats that allows us to apply the same configuration to multiple channels. And so the question could be, can I have multiple sinks for a single channel? Let us see. Maybe that has not been decided yet. Okay, so do we get multiple sinks for a single channel? I don't know yet. Maybe we don't need to support that to start with. So let's start with assuming that we can have multiple channels going to the same sink. So a single sink is shared by multiple channels, but a single channel goes to at most one sink. Cool. So how to make this work? So their logging package instantiates channels and the mechanism behind them when the CockroachDB starts. And so there is an initialization phase where whatever is configured is taken into account. So we could delay analyzing the configuration to that time, but I find it easier as a user to see if my configuration is mistaken before the software tries to do anything with it. So what I think we can do here is to parse this configuration, analyze it, and create an internal representation of the configuration, analyze its correctness, and then if there are any problems with this analysis, report it early, and then only later take the configuration into account to instantiate all the looking data structures. So this is a case of a configuration language for which we need to define internal data structure and then write a parser for them. So a lot of problems in programming can be reduced to making parsers and configuration. So that's okay. What we also see is that the parsing language is kind of simple. We have on every directive 3 parts separated by colons. First part doesn't contain a colon, so we can assume it doesn't, and then the second part does not contain a colon typically, so we can split at colons to start with. And then the parameters are going to be key equal value things. And some of them don't have a value, they're just a key. So the real language is a sequence of comma-separated key value pairs where the value is optional. So we're going to do that. The first part is a list of channel name patterns. The stars are allowed. So I don't know if I want to make this a full glob pattern, or we're just going to restrict to just stars and values delimited by commas. Yeah, maybe that's what it says. Yeah, so either a star, a single star, or one or more channels delimited by commas. So the way to do this, anything that looks like a language that needs to be parsed, we are going to start by defining in code our understanding of the structure of that language, which means we are going to define an abstract syntax for it. And yeah, this is an exercise in defining data structures. Cool. Let's go and define some data structures. Configuration. Do I want this in this package directly? Yeah, I can move it later. Configuration.go. No, why do I have a tags file? Let's remove that. No. Tags. Yes, thank you. Package log. And so we said I'm going to copy paste some of these examples here in some comments so that I have them nearby for analysis. All right. Oh, and I did one example with a star. So what do I have here? We have 3 parts. So a log configuration is composed of 0 or more configuration directives. Let's call it config directive. It's going to be a struct with some stuff inside, which I don't know yet. And then a config is a list of config directives. What do I have in one directive? We have a channel specification, we have a sync specification, and then the parameters for the sync. So what we really have is a sync configuration. All right, so what we have here, and then we have channel spec. Okay, what is a channel spec? Channel spec is an interface. So what we're doing here is a marker interface. It doesn't really define any useful methods, but because we want to create a union type, and we don't have union types in Go. So instead we're going to define our union types with Go way, which is a bit strange, and that is done by having our instances of that union implement the interface. So a single star is going to mean all channels. It's an empty struct, and we are going to implement the spec method for them. And then separately, we have one or more channel specifications, which are going to be channels. So we have a channel type now. What is it called? My editor is being slow, needs to be started. Language server needs to be started. That's what we're seeing. Yeah. Let's see, Go facilities on a code base that's multiple gigabytes large. Not exactly fast. So I think has to reload all the source code in RAM the first time around. So it takes a little while. It will come eventually. Yeah. Let's see what it's doing. Let us see what it's doing. So what we're looking at here is the Watchman follow facility, and it's done. All right, so a channel is a channel, and channel is just an integer. So I could implement this. Well, the channel type. I want to have a channel list, and then I'm going to say func channel list is so I can fit either all channels or a channel list inside my config directive. And then a sync configuration has a sync name, and then key value pairs with values optional. So I will call them options. And an option pair is option pairs is a list of option pair with a struct, and the value is option string. All right. Now, this is the abstract syntax, and because we have an abstract syntax, we probably are going to be happy being able to print out this abstract syntax back into its original format. That's a very nice way to ensure that we're not making mistakes. The process of implementing a string representation for those things allows us to check whether our abstraction is correct. And so we're going to do this. If I have a config already and I want to format it into a formatting buffer, I'm going to do this by implementing a loop. So the directive, I'm going to have one per line. And so I'm going to say directive.format. Let's call it run, and then sprint write. Do we have IO? I think IO.write string. And a line, new line. Is that something that exists in Go? I don't remember. I think it does. IO.write string. Yeah, look at this. Excellent. Could probably do write rune. Maybe. Does it have write rune? No, I don't know. All right. So this will create a formatting of all the directives one after the other. And then we are going to format those things. Some people might sometimes choose to implement a string method in Go. So string method is a common way to transform something into a string. I don't personally like the string method because it causes excessive heap allocations. The format methods can be chained by method calls without having to copy data around. They can all emit to this fmt.state. And that's my preference. But we can make a string method out of a format method easily if we wanted one later. I might show how if needed. So we have a config directive, and how does that look? We're going to say that a config directory starts with the log equal sign, then we format the channel. I don't have to write this. I can actually try formatter here. Then I say it's a spec c.spec.format and R. Then after this channel specification, I have a column. Then I format the sync specification, and then I'm done. So that formats the first part as from the specification of channels. Actually, why do I say a spec here? It's chance. Oh, I'm forgetting that I'm supposed to show my key presses. I forgot to start the key press thing. So let's do that. Show keys. Yay. All right. And then the sync. And then the sync configuration. So we want to implement all channels. That's an easy one. The all channel thing is just a start. And then the channel list is going to be, channel list, sorry. We are going to make a comma delimited string. So comma starts empty, and then channel range CL. We are going to write the name of the channel. So what is the name of a channel? pb.go. And do we have a list of channels somewhere? That would be great. Yeah, look at this. Channel value. No, that's channel name. Channel name. io.writeString, the channel name, and then a comma. And then the comma changes structures. All right. And that was the channel specification. And now we want to format the sync. Let's take this by reference. Do I need to take the other things by reference? Yeah, let's do this. Doesn't hurt much. Sync configuration. We are going to format the configuration sync name, followed by a colon, and then its option pair list. I could create a format method for the option pair itself. Maybe. Do I want to do that? Or am I lazy? No. Let's do it like this. And it's going to be the same story as earlier. Comma stays empty, continues like this. And then we have io.writeString, the option key. And then if the value is not null, io.writeString, the equal sign followed by C value, except that it's a pointer, so I do it like this. Oopsie. Now my editor is complaining that I have somewhere a mistake. Oh yeah, for range. Yeah, thank you. All right. Time for testing. Time for testing. Configuration underscore test. And am I using a different package? No, it's the same. Func and then test configuration formatting. And so the way it works, the idiom here is to create some pairs. So I have a configuration, and then I want to expect some format out of it. So we have test cases. And each of the test case is a config, and then an expected representation for it. The nil config is valid, I think. I don't think I can implement something by pointer on a list like this, so probably I need to do it like this. So a nil config is possible. A nil slice in Go is empty slice, and the expected string for it is empty. I can also have a non-nil slice that contains no element. That will also have an empty representation. And then I can have config directive that are not completely empty, and these will have non-empty configurations. What is the minimal config I can have is one for the all channels. So all channels, and for a sync that has a channel, a given name and no options. That is the minimum I can have. And I have just one config, and its representation will be just one line. All channels is a star, then this, and then no options. So that sounds all right. And let's indent this a little bit so it looks nicer. Do I like the fact that this colon here is a bit alone at the end of the line? Do I want the user to say, oh, I want a file, but I don't care about any options? Like, do we want to make this colon optional? Well, I don't know, but let's see what the RFC has to say about this. Maybe my RFC has some suggestions. The parameters can be further omitted. The simple parameter is no parameter. There we go. That means that here, when I was configuring showing my configuration, I made a mistake. So I need to do, if I don't have any options, then I immediately stop. I only print the rests if there's something to print. And so in this simplest configuration, I don't have a colon at the end. All right, let's check this works. Why does it complain? Package log implements. Why do I get a red color here? It tells me that there is an error somewhere. Nah, I don't know yet. Let's try this. For test case in test cases, I'm going to take the config. And print it. And then compare. All right, so is required.equal. Oh, it needs the testing thing, and then the expected first and the actual second. So testing thing is the first, and the expected second. And now I can run this. Missing function body. See, I made mistakes. Let's go. Yeah, a method definition needs a body. These are marker functions, so I don't care. Cannot use a channel as an int. Yes, because reasons. I'm okay with that. Comma declared but not used. So I make another mistake. Yeah, I need to write the comma at the end of the option key pair. And now I wait. I wait for the thing to build, compile the test binary, and then run it. I'm optimistic. Maybe I will have made a mistake, but I'm optimistic my test is helping. Maybe my IRC is telling me actually is that the list of possible sinks is finite. So I have a fixed list of possible sinks, and the list of options that are allowed for each of them is also limited. So in theory, I could have a more specific typing. We could have a data type for files that has a specific options for the file configuration, and then if we add more different thing types and have different data types in Go for them. I think that is maybe premature, but I'm going to keep it in mind. It's possible that we will want to do that so that we have more specific documentability, like the code makes it is easier to read if you have the discrete fields. But at this point, I still want to investigate this a little bit. So what is this error telling me? Well, I'm adding a new line character even when I don't need it. So that's actually kind of a bummer. So let's do the same thing we did with the comma before. And so this thing we do with the comma is this. Comma starts empty. Comma is a new line character. So someone could be unhappy that I call a string that at the end becomes a new line character a comma. That's because this way I don't have to think about the name. I'm always using the word comma everywhere and using this code pattern. All right, this is probably all right. Let's add a second config directive. I'm going to group them together so it's a bit more compact, and then make two of them. And then I'm going to have this something like this. Oh, look at this, I made a mistake. The IRC says singular. Testing is good. It checks the expectations. Oh yeah. I want two directives inside a single slice. All right, so now I'm getting there. I also want to have a test that tries with a different set of channel. And this one, I want to have different oops inside it. And let's run that. There's something a bit long about this testing here. So here you see these test runs every time they take multiple seconds. That's because every time the thing is compiling the entire test package for the log directory, which actually contains quite a lot of code. So that makes it pretty gnarly and makes my iterations annoying. I could choose to have this configuration occur in a separate directory. So my iterations get faster. And then after I'm happy with the configurability, I can bring it back. Or maybe I'm going to do this because I need to iterate fast, and it's annoying otherwise. I might not keep it later, doesn't matter. But it's really going to help me. So let's ignore this. Ignore this. Config. It's going to be in package config. But then now I have a channel which is coming from the log package, which is now a different package. That's fine. And then channel names is also from the logging package. All right. And configuration test is going to be in package config. And now if I try this, yeah. If I try this, it's going to be faster because now I'm not recompiling the log test code every time and get my results much faster. Much faster. I'm also getting some information about my test failures that I made another bug. I'm okay with that. This is what testing is for. So list of channels needs to be separated by I, comma. That is odd. Why do I not get the comma in between the channel names? Channel list? Oh. That is intriguing and annoying. So what we see here is two problems. First of all, my new line character has been eaten, so I was meant. Oh, look at this. I'm not being smart, am I? We need to write the comma before we write anything else at the beginning. So the comma is a separator, not a terminator. There we go. All the tests have succeeded. Cool. And let's suppose I wanted to add some configuration options here. Config pair. How is it called again? Option pair. And here I'm going to have one that's called key with a value. And the other one is singleton key. Oh, I can't take the address of a string like this. Can I take the address of a constant string like this? Maybe? Is that a thing in Go? No, it's not a thing in Go. So if it's not a thing in Go, we are going to make a thing in Go. And now my stdr has options. Key is value, and it has a singleton argument. I made the same mistake with the comma here again. Comma is a separator, not a terminator. There we go. We have an abstract syntax for our configuration language. Now, I said about the configuration of the things that maybe we wanted to have different configuration formats for different sync types. What does the thing have to say about this? So all the things uniformly support the following parameters. So we have some structure, and then the file sync specifically has additional parameters. And maybe that's good, huh? Maybe that's nice. I like this. I like this. I like this. I like this. The thing though, that if I do this, I will need to write a lot of code to print out those things. And that seems a bit annoying, isn't it? But it's not that annoying because I can do something. I can do some reflection on the code. Reflection is nice. So I think I like the idea to have structure, especially because this way I can have those fields captured in a structured way, and they are common to all the configurations. But I will want reflection. I'll take it. I'll take it. So now we have this very generic sync configuration, and I just decided I don't like it. And so we are going to turn this into an interface, which is also a formatter, and it's going to have a sync name, which gives it a string, and a config, but the config is hidden inside. Then I have a common sync config for all the fields that are common. These are listed here. Yeah. So the equivalent to filter none implies and so on. I'm going to visit this later when I'm parsing, and maybe the disabled field will disappear as a result. We'll see. Is a boolean. All right. And then we have a file sync config, embedding a common sync config with additional fields. So what you see here is that I'm using my specification to seed the struct. Size, max group size, prefixed string. All right, and then we have stdr sync config. It takes everything from the common one, but nothing else. All right, and now the thing we'll want to format. So severity is a thing from the log package, so we can keep it. And now we want to show all this to the user. So here I could do a thing with a manual printout. So I could say, so I'm going to, well, first of all, I'm going to implement the names of those things. So file sync config has a name. Func file, and then the other one has stdr, and then the format here for the sync config. Where was this? Sync configuration, sync.format. So format has a thing, but we are going to first actually we're going to do it options. I'm going to remove the formatter interface here. Formatter is a complicated interface to implement, so I actually don't really like it. But I'm going to have sync options that are going to print out the option. Oops, no, string options. And then here, I'm going to do this. So if I do have sync options, they're not empty, then I show them. After a colon. All right, and I want the sync name first. There we go. So now the test is broken for the time being. I'll fix it in a second. I do want to implement sync options on those things. And to do this, I'm going to do sync options on the comment sync or the file sync. I could do them one by one, but I actually don't need this. What I can do this is a generic sync options thing. So func generic sync options. Sync options. I'm going to try this. I'm going to use reflection. I'm going to try to use reflection to format my options. So I take some config without knowing its type. And I'm going to return a string. And to do this, I'm going to use the magic of reflection. Now, I actually don't remember how to use the magic of reflection, but I do know that there is something in the magic of reflection that's called reflect.value, and I know it's used somewhere else. And so I'm going to go and peek at what other things are using reflection inside our code base that is using fields. And I'm going to mimic what they do. So where do we get this? Reflect.value is not super interesting. I want reflect.field because I actually want, shit, that's not exactly what I want. Reflect.value. That is a good one. I like this. I like this because that has a field. So fields are record.fields. So what is this? Record.fields. So you see here, we have data types that are structs, and the data structs, when going through reflections, they have a field method, and I can enumerate my fields this way. So v is going to be reflect that value of my thing here, and I use lm because I know it's going to be passed by pointer, and then I'm going to use fields. So how does it fields? So I need to look at the number of fields because I don't remember how the so I field by name, field by index. Do you have a field num field? Do you have maybe num fields? Something called num fields? Oh, hi, the Portuguese captain, Ricardo, that would be. Num fields. Look at this, we have the number of fields in the struct. For I is 0, let's call it. I don't remember the semantics. Can you do for I in range and number, and then it will iterate through the number and go? I don't remember. Probably not, right? All right. v.field of I. And now I have a field, and what I can do with this field is get its name and get its value and its type. So the value itself is something I can cast. I don't remember how it works. If I want to cast it to something, field.interface the current value. That's great. That's exactly what I want. And the name. So I'm going to print out the name of the field. And then depending on whether it's a Boolean or not, I'm going to print its value. And how do I know whether it's a Boolean or not? I'm going to look at its kind. So if the field.kind is reflect.boolean, then, or it's not a Boolean, then we're going to print an equal sign followed by the value. And how do we do the printing of a value? We use the magic print function, which is able to convert any value into string. And everything that's a Boolean will get printed as is. So do I want to print the Boolean name at all? Actually, that's not the case. So we are going to do it this way. If it is not a Boolean, I print the name and then the value. And otherwise, it is a Boolean, then it will depend on the Boolean value. So field.interface convert to reflect.bool. Oh, it's a kind. Wait. It's a kind. Is it also a type? What is the type of bool inside? Yeah. So what I'm doing here, I'm converting the value inside my struct into a Go Boolean because I cannot extract the Boolean directly. In the case where, for example, one of my fields has been type def to a different type in the struct, like if I had done, for example, type my bool, and then I use that type inside the struct, and if I try then to convert the field into a Boolean, if I try to cast the value of the fields into Boolean directly, I will get a Go panic that the value is not a Boolean. So what I'm doing instead, I'm taking the bool, converting it via reflection into the actual Go type bool, and then convert that to a Boolean. And then, if my actual bool is true, that is when I print the name of my fields. If it's not true, then I don't print the name and I don't print anything. As before, I'm going to print my comma, which is going to start empty. And then at the end, I'm only going to change it if I printed anything. If I did not print anything, then the comma doesn't change, so that's the next field. I'm not printing anything still. There we go. Fingers crossed. These generic string functions now I can use to implement the file sync config sync options method. Yeah, so sorry, this is a function returning string. And now I can use that. Generic sync options of this. And then the other one, same. Ta-da! This way I can add more fields into my struct, and they will be automatically handled by this reflect magic we have here. It is time to test again. So this string configuration is not a struct anymore. Now I have file and stdr string config. So I'm going to start with a file sync config. Doesn't have a name anymore. Doesn't have much. I'm going to keep all the values as defaults. All the values as defaults, and then hope for the best. Except that it wants this to be taken by allocated on the heap. And then I'm going to do the same here. And then here we have going to have a stdr sync configuration. And then the test case here is not going to work anymore, probably. Config. The test is not going to succeed, obviously, but I just wanted to show me Oh, what possible Go mistakes I have made. Field.name doesn't have a name, does it not? Oh, aha, field by name, field by index. So the field extracts the value of the field. It does not extract an object with a name. So I actually need something else. I need to find the name of a field. So how does it get a field name in Go? Must exist. Why do we have field name func, field by name, field by index, field, name field? That is kind of a bummer, is it not? Oh, I need to access the type of it. Ooh, here I'm looking at the value thing. So field, and then field name. Do I have a field name? Do I have a field name in this? That would surprise me. Struct field. Look at this. Field has a name. There we go. Okay, so reflects doesn't exactly work the way I thought. So I don't have a field name. What I do have, this field is a value here. So field value is this. Field value here and field value. Field name is not a thing. So what we do have instead is a field type. Type field by index. And now the field type has a name. And it is here that I have a kind. There we go. That looks better. For I, field by index takes a nested field corresponding to the index sequence. Oh, I just field. Why do I use field by index? fmt.writeString, so that would be buff. That is now a string thing. Does not implement sync configuration, missing a sync name method. Is it? Oh, look at this. It's supposed to be sync name, not sync config. Yay! Better. Value is declared but not used. I'll take that. Aha! Now we are talking. I was too optimistic. So what this is telling me is that reflection cannot help me access fields inside structs that have not been exported. I will accept this to be true. And I still really, really like to have my reflection, because I really don't want to enter the business of caring about formatting individual struct fields. And so I will do what it says. Why is it not happy? Why is it not happy? I need to learn about this. So what's going on here? Reflect.value.interface cannot return value obtained from an exported field or method. Which one would that be? I actually don't know which one that would be, but we're going to ask it to tell us about this. And how do we do this? We do printf formatting. We want to know what field that would be. is a common sync config. It's not exported. Indeed. Yeah. Better. Much better. Look at this. The common sync config has been printed as something here. So here I'm encountering some annoying little fact of life, which is that if I embed a struct inside another struct, it's not an inheritance like C++ does. It actually creates fields inside the struct. And so my simplistic reflection logic is not actually helping me as much as I wanted. So it's not able to iterate on the subfields directly, but that's okay. I'm going to do this. I'm going to pass it directly, and then here I'm going to say config is s.common sync config, and then if C is not the empty string, I'm going to add a comma. It's not exactly efficient. I'm going to come back to that in a second, and then I'm going to pass it the config that I have, and then return that. So I'm going to fix this string assembly here with commas. I don't really like when I'm using string concatenation. That's very that's not very Go idiomatic, but that's okay. I just want to get the abstraction right. What I'm going to do here, I'm going to say is that if the field is a struct, struct, I said, then I'm going to ignore it. So what I get here is that it's going to pass over the basic fields and just take over the other fields. And now I get what I wanted, which is key values without going through the things, and then the file directive gets the arguments. So again, I made probably a boo-boo with a comma, and that's because I need to print a comma before I print anything. There we go. It also prints out the options in capital letters, which is not surprising given that it's the name of the fields. So here we can use a magical feature of the Go type system, which is that fields can have annotations on them. And how this works, there is a tag, and that's a string here on it. So in this particular case, I'm going to invent a name for my thing, and I'm going to use it here. Get log flag. And ditto here. And so something like this, probably. Forgot. Let's try this. Tag. Yeah, why? I don't like completion. There we go. So what we see here is that now it's extracting the log tag names from the flags, and so where it finds them, it prints them out. So also that is weird though, because is it not the way it works? How do tag name work? I don't remember. Key colon value. Oh, look at this. I made a boo-boo. Key colon value. Yeah? Yeah, look at this. Look at this. There we go. We are going to do this. And then if it's not there, and strings. This way, we only need to add the annotation on the struct if the name that is automatically generated is not nice. And so this one is fine because it's going to get lowercase to the right shape. All these are also completely fine. This is probably fine too, first store. And so max file size is the one that's going to be different. Log flag name max file size. And then max group size. There we go. And then I get my get field name here. Here. Does that get right? Look at this. That looks much better, doesn't it? Now, what we're also going to do is that we are going to omit the key value pairs every time the value is the default value for that type. And the reflect package can help us with that too. The way this works is something to do with the types. It has default value is available as a method on the type, I think. Default, no. How does that work again? I'm going to consult the documentation. The reflect package. Is that all it gives me? Oh, that is sad. Construct. Value. There is a way to construct a value out of thin air, and when I do this, I get a default value of that type. How does this work again? It's a 0. There we go. 0 returns a value representing the 0 value for the specified type. So the result is different from the 0 value of the value struct, which represents no value. So that's okay. So that's what we want. So if the value happens to be the default value for that type, then we're going to omit the key value pair. And that we do because there is an equal comparison. Well, there is some comparison method. I don't remember how it's called. Compare, string, type. What's the word to compare values? Field, can interface, con address, field by name, float. I don't remember. Length. I mean, I could do this by printing out the value into a string, and then compares the strings, like the representation of the value. Oh, look at this, E0, that's even better. Oh, look at this. Oh, man. That is so, I don't even have to compare. That is so amazing. So, if it's not reflect.bool, And also, if the field value is not a 0 for its type, then I do the thing. Look at this. The file, all the options for it have disappeared. This TDR has no options. Oh, sorry, I was looking at this. So all the things have disappeared, and that is copacetic because I have no options. And so because all the values are at their default, sorry, all the fields are at their default value, then the code that I've wrote just does the job and will not print anything. So this one is fine. And so for this default configuration, this TDR also doesn't have any option, and then this works. There you go. So that succeeds. And now we're going to play by having some file sync config with a non-standard. So I'm going to say max file size is 100. And then I'm going to say this tr sync config is redacted. Redacted true. Yeah. Now it's going to say redacted capitals. Thank you. And then it's going to fail, telling me that I have a redacted flag here. It's exactly what I wanted. There we go. Look at this. Our printing code works. We did not have to print out fields individually, one by one. The reflection code does this for us. What if we also wanted those sizes to be byte quantities? There is a package, I think it's called humanize util here, that has something called bytes. Byte sizes. So I could have something here that is represented as bytes, something like this. Humanized iBytes. Actually, that's even better. Look at this. That's the. Okay, let's do this. Let's do this. So I want my file size to be a size. Type byte size int 64, u int 64, thank you. And then I'm going to have okay. And then I'm going to do a byte size here. And then try this. 100 bytes. Oh, look at this. That is not nice. The humanized util gives me a B that is separated with a space. That is not great. I don't like this. The size is spaced out. Ah. No. No. No, I don't want the spaces. Spaces are not nice. It is for the greater good. Yes. There we go. 100 bytes. 100 bytes. Now, I have this woo thing printed out. I don't need that anymore. And I also want to fix my configuration expected value. So suppose I were to say 100 megabytes. There we go. what did we achieve now? We have a abstract syntax tree for our logging configuration that recognize channels and different types of sinks. Each of the sinks have their own data types for its configuration fields, and it's able to pretty print itself as in the same format that we want our parser later to recognize. The advantage of doing this is that we now have this general pattern of programming parsers, which is that once we have implemented parser, we can test it by having parse something, pretty print it, and verify that the output of the pretty print is equivalent to the original string. That's a general way to test parser and parsing code. And that was the second half of the parsing code I just created here. So that's going to enable me to test the parsing code successfully. And so what I just said, we are going to implement now. We are going to implement the test before we implement the code. Test-driven development for everyone. Very good. Test parse configuration. And so what I'm saying here is that we're going to have some test cases are going to be strings, simply, actually. And we're going to verify that they are preserved throughout the parsing. And that there is no change. And so we do this like this. Why is it not happy? Oh, it is happy. We're going to parse it. Is going to be parse configuration. Yeah, so here there's something else I need to explain a bit later. So my configuration is only going to be the value on the right of my equal sign. I'll get there in a second. Do I want to get there in a second? Actually, maybe not. I'll get there. I'll get there in a second. Pass configuration, the test case. If there was an error, I'm not expecting an error, the test fails. Then we are going to say that the result of printing this is going to be a result of converting the configuration to a string. And now I'm going to say require.equal the config, the test case and the result. So I'm saying here that the after I parse my config, the config is going to be what it is. I don't know exactly what it is, but when I print it back to a string, I want to see the same thing, which is going to be a guarantee that all the information that I had initially is going to be preserved through my configuration. So of course I don't have yet a parse configuration function, but I can prototype it. Here, func parse configuration, log flags string, and it's going to give me a combination of a config and an error. Config is a slice, isn't it? Yeah, it's a slice, so no need for struct. An exported type config.config. Let's not export it for the time being. I am okay with that. Yeah. I'm not going to do anything for the time being. And I let my test fail. So what it's telling here is that after parsing, after parsing this command line here, the result of parsing is a config that itself pretty prints as empty. That's right, because my parse configuration has not done anything. And so the result is empty. Well, for now, that's okay. And now we're going to add code inside the parse configuration to do things. Before I do this, however, I need a break to get some tea. So the stream will be back in 5 minutes. I don't know. I need to make a comment here. So stream will be back in 5 minutes. At 5 to the hour. Yeah, if there's no time, obviously, we need to announce the time. Okay. We are going to resume in a minute. It's also important to move and do some exercise while programming to ensure that the arms and the back are not twisted all the time. And here we go. Cool. The parsing for this configuration format is not super complicated, but we probably will have some work to be doing for the key value pairs. All right. So first of all, we will have a list of multiple log flags. Well, you know what? I'm going to say, let's go for a single directive. I'm going to tweak my formatting a little bit. Before I go for parsing, I'm going to say that the responsibility to print the log prefix is going to be in the config object, and then I don't have it here. So here in the log config directive, I only have the inside the triplet channel sync parameters. Doesn't change much for my printout tests, I believe. That still works about the same. Yeah, except if I forget to put an argument. So the test here doesn't change, but it does allow me to make a parser that only take one log flag without the logging prefix. And that means that my formatting code, my test code can skip testing the log prefix here. So what I really want is test cases are just one string, and then the config is a directive. And then I print that. Except that it needs to return a config directive. And this test is still failing because, of course, inside there is nothing, so it's confused. I'm okay with that. Nothing inside, confused, everything is fine. We just have to parse it. You know what? I brought back my tea, but I forgot to bring my cup back. I need my cup. And a cup. We have a cup, and with a cup, the tea exists. So a single log flag has three parts with colons. The third part with the arguments might also contain colons. So we only are interested in the first two colons. And to do that, we're going to split the string with a maximum of 2 colons. There is a function in Go for this. Split n. And I want 3 parts. I think that's the way it works. And most n substrings. Yes, thank you. And if I need to have at least 2 parts. The last part is optional. So if the length of the parts is lower than 2, I'm going to say invalid configuration, expecting channel spec colon sync spec. Okay. If I have 2 or more parts, I'm okay with that. So the first part is going to be my channel specification. So we're going to parse this first. And there are 2 cases. If parts, the first one is a star. And how it's called? It's called to be a channel spec. Then the spec is all channels. Otherwise, then we will have a comma delimited list of channel names. So candidate chance is strings.split of the parts at the commas. And then now we're going to assemble a list of channels with this. And how's it called? How's it called? It's called a channel list. Varchance channel list. Right? And then we're going to try to find channels. First of all, we're going to be very flexible on the input and trim the output. Trim the string. So that we remove spaces before and after. So that's like a general principle. Be flexible in the output, be strict on the be flexible on the input, be strict on the output. That's the Unix design philosophy. This is why the user can make mistakes, will tolerate the mistakes. We tolerate the mistakes. That means we also probably want to trim spaces around the star as well. And then we're going to have channel names. So that's like the names in the log package, which we now have here. And it's really nice because we have this channel value map. And so the name is going to be toUpper. And then we're going to have a lookup with the candidate name. And then there are 2 cases. If not okay, we're going to say it's not unrecognized channel name. And we probably want to tell the user about the list of valid names. And so we're going to compose a hint. Do I want to do this? No, I'm going to do that later. Just polish. Too early for polish. And otherwise, we do have a valid channel. So we can say chance is chance with this. And now chance spec is chance. There you go. So first part, list of channels for star to mean all channels. Second part is going to be the sync name. Cool. And so sync name input and we're going to tolerate it by taking the lowercase version of it. And then we're going to have a switch with a default I'm using new with a formatting string that needs to be new. And then str and then file and then sync configuration. File sync config. So it's about all right. And otherwise nothing. And now I have, as a result, my chance is my chance and my sync config. Sorry, and my sync is my sync config. We're getting there. We're getting there. I'm still not parsing the arguments that come after the second colon, but I should already see some progress in my testing here. Trim doesn't work like this. Trim space maybe, yeah? Yeah. So what I'm expecting now in my testing is that it's going to say fine for this. Errors.new is not recognized. That is sad. Why not? Oh. We have our own custom errors package. That config is not an expression, is it not? It's a directive now. Huh? Ta-da! So what's working here is because my file directive here doesn't have parameters, so because my parser doesn't recognize parameters, it's not going to parse them, but it's also the default printout of no parameters is empty string, so it works out pretty fine here. I did add some error messages though, and since we have error messages in the code now, probably we also want to test the error behavior. So the way to do this, we're going to have a struct here, and that struct is going to have an input config as a string, expected error as a string, and then if the expected error is not set, then we expect success, and if it is set, we expect an error. And this way, the test case here is no error expected. But for example, suppose that we were to omit the thing here, then we expect the error message here to tell us that we need to have two parts in the thing. So that's what we want here. And I'm going to take this here like this. All this is unexpected invalid load configuration. So once I embed this thing into a larger configuration system, I will add a prefix to the error message. And so what does it say here? till.isError t fatal error f. T fatal F, fatal F. Test utils, test utils. Cannot use TC type struct, yeah, because now I have an input here. Expected error, invalid load configuration, got unrecognized channel name empty. Oh yeah. All right, that looks about all right. Better. Not equal, expected file got nil. Yeah, so if I don't have an error, sorry, if I do have an error, I don't go further with the test. And otherwise, no error. That's when I want to check our configuration. That's where we are. That's where we are. And unrecognized channel name, unrecognized sync type. Yep. Yep. If I have an invalid name, what would be a nice name? Captain Kick. Yep. Cool. There we go. So star is fine. Dev is fine. And what would be another one? Would be ops. Ops is fine. And we also said that stars, spaces before, after are completely fine. All this is completely fine. Oh, that makes me sad. That makes me very sad. I'm fine with the thing being being represented the same way that it was input. So that's not exactly true, because we are more flexible on the inputs than the outputs, and so the result of the printing out the thing is not exactly the thing that was input by the user. So the algorithm we want is one step beyond that. We are going to print out the things and reparse it, and then expect that the result of reparsing is the same as we got the first time around. So we're going to print this, and then we're going to reparse it. The second time around, we definitely do not expect an error. And then we're going to print out the result. And then we are going to say require.equal equal values, or equal, what is the difference between equal values and equal? I don't remember. T parse config results. So after reparse, we're reparsing the same thing. Except that I don't remember the difference. Two objects are equal, inequality of their reference values. And what is equal values? Are convertible to the same types and equal. Okay, I don't care. Equal is just fine. And then we are requiring C config directive. This way, we tolerate when a printout doesn't look the same. Expected error, dev file, dev file. Yeah. That doesn't tell me though that it's parsed properly. That means that I was a bit too simplistic. We do want to look at the result. So if the parse fails, there is no result. But if the parse succeeds, we do expect. And then that's now where we are going to put our expected cases. And now required equal t expected is tc dot expected. Then reparse config. That's fine. There we go. So this is necessary because if I was doing it the previous way, the way I did it the first time, I could have a parser that didn't do anything, and then the printout would be empty. But because I wasn't checking it, I was just checking that reparsing afterwards would produce the same results. Then I was actually not verifying that the parsing did work properly. So that buys it. So we're done for the prefix and the sync configuration. Now we have to parse the key value pairs that come afterwards. And so here I could perhaps have fun and do parsing of the individual key value pairs and then hope for the best. But I really don't like this idea, not at all. And so what I'm going to do instead is use reflection again. And hope for the best. And after that, we will be done for today. So that will go quickly. Let's see. We have our sync config here, and we need to assign the values in the last part. Then parse sync config. And again, I will be in a moment flexible about spacing. Cool. Now the options are separated key equal value separated by commas. Split. And then each of the key values is possibly separated by an equal sign. So var value string. And then no, that's not right. If is parse is splint, just 2 parts, and so 0 value is parts of 1. And now we have parse sync option, sync config key value. Okay. What I'm doing here is I'm cutting my problem space into subparts. This function is doing all the options separated by commas, splitting the equal sign to extract the key and the value part, and then delegates to this new function the task of doing something. And this is going to be able to return an error. And so all right. Cool. So reflection. So we have a sync config, which we know is a pointer to a struct. We have a key, which we know should be a field on that struct. And then we have a value. And then the semantics we have is that if I'm looking at a Boolean value and the value is not provided, meaning the string is a nil pointer, then I'm going to assign false. And if it is provided, then I'm going to convert it to the struct field type. Sure, let's do this. And I'm happy because I have some reflection code here that I can use again. So I have my struct. And then now inside this, I want to find whether there is a field with a given key name. So here I have two cases. Either I have a field directly with that name, or maybe it's one of the tagged fields. It's kind of a tricky situation. First store. A tricky situation is, how do I look up those fields? I have no choice but, and that is to find the field. To find the field, and we need to find okay. So field index error field for the key. Oh, that gives me a value. It gives me a value. Is it possible to assign a value to a field inside a struct with reflection? I think that's possible actually. Set. Yeah, I think that's the value, reflect value on a struct field gives me a pointer to the struct field, and so I can assign to it. So I'm going to start simple. s.type.field kind type kind kind.bool flex.bool, and the value is not nil. Then I'm going to say field.set bool true. Let's start with this. I'm not handling the other types for the time being, but I think that will show whether my thinking is right. And so we need to find field on a type. And here I need something called field by name func. Is that the right thing? I think it is. Returns the struct field with a name that satisfies the mass function and a boolean indicating if the field was found. That is not right. I don't like that. I don't like that. I don't like this. For and there we go. Null, -1. No configuration option with name. Cool. I think that's good. That is good. Let's not make it a full, complete, obscure sync configuration, because this way I can wrap this name so that I can have the name of the sync as a prefix in the error message. So this code here is still going to be confused about the embedded struct. So we have this embedded common sync config in the struct. And so I'm iterating through all the fields, and I'm not going to encounter the fields inside the common sync config this way. I need to probably to reflect, to recurse on the type, but I'll do that in a second. I just want to check now that my reasoning has been effective by checking whether I can parse simple Boolean flags, for example, audit and first store. And the way to do this is I'm going to take file and audit, and it's going to parse it. Is it? New. Aha, look at this. I made a mistake. What is it telling me? Out of range with length 1. I say split n. more than one part, of course. There we go. So the audit flag was recognized properly. And if I use a flag, not a field, the parsing is going to fail with an option, with a no configuration option. With name. There we go. I have more or less found a structure that enables me to add sync types and their own configuration options to my package without having to write manually parsing code. The parsing code and the printout code will automatically recognize all the new options and generate command line option parser and a printout function that does the right thing for those flags. So what I did not do yet is recognize during parsing non-Boolean values. For now, just Boolean I recognize here, like I want to add support for the sizes, and also is not able to assign on the base type. Oh, actually, there is some kind of redundancy here, which I need to come back later. And then probably after that, connect that to the actual command line. All this has been inside Go with the Go test unit testing. I'm programming towards the command I can run on the shell that pass the command line, and then it will do the right thing. And that is plumbing, more or less. And so I might do this asynchronously. And so this next time we can go about connecting this infrastructure to something else and files, and maybe going to logging to the network and things like that. So that was for today. Thank you for watching, and see you at the next iteration of the stream. Thank you all.